I'm getting some questions about the Sturm-Liouville problem, so I thought I would go through case 2 and point out some common mistakes. So most of you are getting, or should be getting, the general solution: a cos square root lambda x, b sinh square root lambda x, and if you plug those into the boundary, calls them the initial conditions, you get a plus b square root lambda equals 0, and a cos square root b lambda times 5, b sin square root lambda times 5 equals 0 in my case, because in my case I have y of 5 is 0. Okay, so then taking the first one and solving for a, we get a equals minus b square root lambda. Take that and plug it into the second equation, factor out the common factor of b, and you get minus square root lambda cos square root lambda times 5 plus sinh square root lambda times 5 equals 0. Now, assuming that b isn't 0, which would be kind of pointless to have b equals 0 if you don't have to, then what we're asking for is, so solve this equation for sinh and cos, and it simplifies to hyperbolic tangent. Don't write it as sinh over cos, simplify it to hyperbolic tangent. Now, remember what we're doing here. We're trying to solve a Sturm-Liouville problem. So a solution to a Sturm-Liouville problem is going to lead to an eigenvalue, and an eigenvalue is a value for that parameter lambda that gives a solution to the entire differential equation, and with the initial conditions. So, quick review. This is the solution to the differential equation. This requirement, which is this requirement, gives us the initial conditions. So we have to have both, and this has to be satisfied. So how do we find a solution to this? Well, looking at a graph of hyperbolic tangent of square root lambda times 5 and square root lambda, then what do we get here? Well, first of all, you have to figure out which graph is which. So I would use wolfram alpha and just graph hyperbolic tangent 5 square root lambda equals square root lambda. You don't even have to do that because you're also going to have to solve this thing. So you can just type solve hyperbolic tangent 5 square root lambda equals square root lambda, or if you put a double equals in it, then wolfram alpha will recognize that you're trying to solve this. As part of the solution, it shows you a graph, which leads me to believe that we are looking at, well, let's see. It's going to be A or B, right? So let's go back and look at this again. This goes up pretty quickly and then tapers off pretty quickly. So I'm going to say that we are looking at case A. And there are how many eigenvalues? Well, the eigenvalues are where we need this equal to this, or where the graphs intersect, which is exactly in one non-zero spot. So 1. And the eigenvalue is the spot where they intersect. So if you look at wolfram alpha, then wolfram alpha actually gives you a value. Now it's not accurate to very many places. So there's a button down here. Where did you go? Oh, more digits. There we go. So get more digits than copyable plain text. Control C. Of course, now it's going to bring in all the lambda stuff, so I'll get to delete that out. And there is your eigenvalue. So when it comes time to do the eigenfunction, you just plug that lambda into the general solution up here. But remember that with a general solution, we now know that it actually looks like this, with an x in it, because we know we have to have this condition. So the general solution is actually going to be, I'm going to type it here. Oops, I forgot about, I was going to include that lambda. So I'm going to put that eigenvalue in for lambda. Of course, this is going to mark this wrong now. Should just recopy this. All right, so this is the eigenvalue, and then when you plug the eigenvalue in to the function up here, you get the eigenfunction. So I'm plugging lambda in, but remembering that a is minus b square root lambda, so it simplifies to this. So hopefully that helps. Now, if you have to find more than one eigenvalue, in this case we don't off this graph, but if you encounter a graph, if your graph happened to look like this, where you need more than one eigenvalue, then Wolfram alpha will do that. So sine 5x and 1 over x are graphs that are going to intersect each other a lot. And Wolfram alpha is going to give you a bunch of solutions. So it gives you all of these solutions here. But if that's not enough, I only got 4 positive solutions, and if WebWork was looking for 5, I'd be missing 1. So I want to know what's the next biggest one. So I want a solution larger than 3. So what I'm going to do is I'm going to, so you have to type it in this way. It's a little bit weird, but basically you're forcing Wolfram alpha to look at 2 equations, this equation and this is an equation. And what this says is I want the distance of x from 4 to be less than 2. So I'm looking at all the numbers from 2 up to 6 in this case. And that should give me one more solution larger than 3. So if I do that, it's going to solve this. And look, I get a whole bunch of solutions here, larger than the 3 I originally had. So that will give you plenty of solutions if you need to do that. A lot of times Wolfram alpha will just go ahead and give you 5 solutions, and you won't have any issues. In fact, you might even be able to force it to give you the first 5 here with a little bit of cleverness. All right, so hopefully that will help straighten out some issues that you're having and get you on the path to enlightenment.